on the tax test, and later on it'll be on your AP chemistry test, and it's such a significant resource because it's sort of a summary of several hundred years of chemical learning and understanding. So I'm going to begin with just drawing the outline of the periodic table. This is just a little sketch, and it has particular features and patterns. All right. There should be 7 rows, so I'm just going to space mine out until I have 7 rows. There's 1, 2, 3, 4, 5, 6, and my bottom one is not very straight. We'll try to fix that. The 7 rows, by the way, represent energy levels. So of all the elements that we've found, either naturally occurring or that we've had to synthesize in a lab, none of them have electrons in the ground state in an energy level higher than the 7th. There's something I seem to have left out here. This is going to be the F section, which has 2 rows in it. Okay. By the way, I just mentioned the F section, so I guess what I need to do is talk about the other sections. Okay. There are some main sections. There is the S section, the P section. Let me finish out this little line here. There we go. So this is called the P section, and this is the D section of the periodic table, and here's the F. And those are going to be important to us. Then we should notice that in the S section there are always only 2 columns. Now a column we also call a group. A row we call a period, a column we call a group. We'll talk about that why in a little bit. There should be 6 boxes as you go across a P subsection, P subshell. Okay. There should be 10 boxes in this D subsection. Okay, and then down here in the F section there should be 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I made that just a little bit too big. All right. On the periodic table, as we said, periods are called, our rows, horizontal rows are called periods, and they represent energy levels. So as we said, there are 7 energy levels represented on the periodic table. Columns, vertical columns, we call groups, and the first one is, group 1 is called alkali metals. It's the group of compounds known as elements known as alkali metals. The second group is made up of alkaline earth metals, and we'll just mention, you hear the alk part there, that has to do with base as in the opposite of acid. That'll be important somewhere else in your chemistry experience. This whole section that we're calling the D section, by the way, I'm going to mark off between the 2 sections. Okay, there's the divider between S and D. Here's the divider between D and P. Okay. All the elements represented in the D section we call transition metals. And then over here in the P section, we don't have names for all the groups, or we're not going to hold you responsible for them. The first one, it's got oxygen up here at the top. That's chalcogens. It looks like chalk generators, right? Chalcogens, but we say chalcogens. And next to it, starting with F, is going to be that group of halogens. And then finally, we've got the noble gases. All right. Another important feature I'd like to point out is that there is a staircase shown many times on periodic tables, and it starts from this, the upper left part of this shoulder here, the beginning of the P section, and it goes like this. What it's doing is it's dividing between metals and non-metals on the periodic table, okay? So sometimes people refer to the elements whose boxes share sides with that staircase as metalloids because they're kind of between. They have properties sometimes of, some properties of theirs seem to be properties of non-metals and some seem to be properties of metals, but of course things that are on the metal side of the staircase, even if they're metalloids, are going to have more metallic behavior, and things on the non-metal side, the top of, or the right side of the staircase, are going to be more non-metallic in their properties. So this is the dividing line, the staircase is the dividing line between metals and non-metals. And I want to point out that some people have the misconception that all the non-metals are gases. That's not true. Of course, this final column is the noble gases, so of course those are all gases. And then we know oxygen, actually nitrogen up here, nitrogen, oxygen, fluorine, chlorine, and chlorine, I'm sorry. Those are all gases, but bromine is a liquid, pretty volatile liquid, at standard temperature and pressure on the Earth. So that's a liquid, and all the rest are solids if you don't count the noble gases of the nonmetals. So we should not say that nonmetals are gases. That's not a, there's not a one-to-one association there. All right. In order for me to use the periodic table as a guide to draw my Bohr diagram, I have to pick my element. That's the first important step. So, say an element's been assigned to me. Let's say it was arsenic, which would be right here. Arsenic. Okay. My first thing to do is to draw something to represent the nucleus. I'm going to differ from the way other people do show their nucleus. A lot of people